Hi, my name is Cheyenne Masters, and I'm going to be quickly going through my lesson plan on quantifying stress using blood biomarkers to study sharks. So, a little bit about me. My name is Cheyenne, and I'm a scientist at the Virginia Institute of Marine Science. I am currently a PhD student, and I study how sharks recover from stressful events such as being hooked, caught in a net, while they're in heat waves or in low oxygen waters. And I mainly do this by taking blood samples to see if there is an increase in stress chemicals, which can tell me how stressed the shark was during or after the event. So just some quick vocabulary for the students to learn. The main one I want to point out is physiology. A lot of people can confuse physiology and anatomy or anatomy and physiology. They think that's the same thing, but the difference is that anatomy is the study of what a thing is in the body, or say, for example, the heart. Like, what is that organ? It's a heart. But physiology studies how that system works or the mechanisms behind that system. So a physiologist would study how the heart works, and an anatomist would know that that is the heart and the muscles in the heart. But again, the physiologist would study how that system works. Um, so we're going to be studying some mechanisms of stress in sharks. The rest of the vocabulary is pretty straightforward, so we're going to move on here. So quickly, there's just an overview of Chesapeake Bay here for any students who don't know Chesapeake Bay or are not super familiar. We can just go over this quickly and then talk quickly about some climate change in Chesapeake Bay, such as heat waves are becoming more common. Oxygen dead zones are getting larger, or areas with little to no oxygen where animals can't survive. And pollution from large cities and commercial industries are becoming more relevant. And then climate change and fishes in Chesapeake Bay specifically. So fish are going to live in waters that they think are comfortable. So it's going to have good temperature, it's going to have plenty of oxygen for them to breathe, and they're going to be happy. But sometimes the temperatures can move out of their range that they like, or the oxygen may not be ideal. And so, usually, depending on the species of fish, the fish is going to try and leave that area. But if they can't leave that area, then they may become stressed or unhappy. And if temperature or oxygen becomes to extreme levels, then they're not going to be able to survive any longer. And so they could die. Um, and so, what specifically is stress when we're talking about if a fish is stressed? So that's when fish's bodies are no longer in homeostasis. So something in their body is essentially out of whack. It can be something visual and external, like a change in skin color, more rapid breathing, deformed fins, or unusual swimming patterns. But most of the time, it's internal and we can't see it. So their blood pH can be too high or too low. They may not have enough oxygen for their organs to work. They can be dehydrated. They can have a decreased hormone or immune function. There's a lot of different things that can go on inside the body, and that would take them out of homeostasis and put them in a state of stress. So here you would just go and ask the students, are they stressed? Pick out their brains a little bit and see what they would come up with. And the point would be is that we can't tell. Um, and how do we find out? We do blood samples. This is just an overview of how we take a blood sample. This is a slide I wanted to show that what sometimes science looks like is not always in a fancy sterile lab with white coats and things like this. It can also be somebody sitting in the bottom of the boat processing samples on their lap with just a couple bins of stuff. And we also want to push for students to understand the importance of replicates in science. Again, the importance of replicates is really important in my studies and in physiology and just in science in general. So this is something great to push along for students. And if you have some higher level students, you can go through specifically what biomarkers they're looking at in the blood. And this is a slide for that. And then also, I wanted to share the importance of collaborative science. I know a lot of students don't like working in groups. I was one of them when I was in high school, but now I couldn't do anything without the people in my team. And so I just want to show students that a big team of people is usually needed to do cool science like this. And that will be it. So thank you for listening to my quick walkthrough of my lesson plan.